Hello friends, today we are going to see some new topics related to our collection framework. Okay, so we will start with the legacy methods defined by vector. We will start now. Void add element, key element, object specified by element is added to the vector. Integer capacity returns the capacity of the vector. Object clone returns the duplicate of the invoking vector, that is cloning. Boolean contains object element returns true if the element is contained by vector and returns false if it is not. Okay. Then next, void copy into object array. The elements contained in the invoking vector are copied into the array specified by array. So new array is created of type object, and from invoking vector to object array, all the elements are copied one by one. Then key element at integer index returns the element at the location specified by index. Enumeration key elements returns an enumeration of the elements in the vector. Void ensure capacity integer size. We have already seen the ensure capacity before this also. It is the same as this one. That one sets the minimum capacity of the vector to size. If first element returns the first element in the vector. Integer index of object element returns the index of the first occurrence of element. If the object is not present, -1 is written. Okay, so it will give you the first index, that is first occurrence of element. Then integer index of object element integer start returns the index of the first occurrence of element at or after start. If the object is not in that portion of the vector, it will return the -1. Void insert element add e element integer index adds element to the vector at the location specified by index. Then boolean is empty returns true if the vector is empty and returns false if it contains one or more elements. E last element returns the last element in the vector. Integer last index of object element returns the index of the last occurrence of the element. If the object is not in the vector, it will give you -1. Integer last index of from start object element integer start returns the index of the last occurrence of the element before start. Okay, it is not from the start, it is before start. If the object is not present in that portion of the vector, -1 is written. Void remove all elements, empty the vector. After this method is executed, the size of vector is 0 because it will remove all the elements from the vector. Then boolean remove element, object element, remove particular element, remove element from the vector if more than one instance of the specified object exists. Then it is the first one that is removed. Returns true if successful, and otherwise it will return false. Then integer void remove element at integer index. Remove the element at location specified by index. Then void set element at a element integer index. The location specified by index is assigned element. Then void set size integer size sets the number of elements in the vector to size. If the new size is less than the old size, then elements are lost. Okay, so it is your responsibility, it is a programmer's responsibility to give the particular size that will be larger than your original vector size. If the new size is larger than old size, null elements are added or padded. Then integer size returns the number of elements currently in the vector. String to string returns the string equivalent to the vector. Then void trim to size sets the vector capacity equal to the number of elements that it currently holds. The following program we will see, it will use a vector to store various type of numeric objects, that is numbers. To demonstrate, it demonstrates several of the legacy methods defined by vector. Okay, so legacy methods we have seen in the table previously. So we will see them one by one in our program. It also demonstrates the enumeration interface. Okay, so first of all, in the main method itself, vector of type integer is created. 3 and 2 is given. Then initial size is v dot size. Initial capacity is v dot capacity. Okay, 1, 2, 3, 4 elements are added. After addition, capacity is displayed. Then again one element 5 is added over here. Then current capacity, again 2 elements are added. Again capacity is displayed. Again 2 elements are added. Again capacity is displayed. Again 2 elements are added. So now first and last element using V dot first element and last element is displayed. If V contains 3, then it will return true. Vector contains 3. Enumerate the elements using enumeration. So enumeration is obsolete. It is not banned or it is not deprecated. You can still use it because legacy classes or code is still there. Those uses the enumeration interface. Okay, enumeration V enum V dot elements. Elements in the vectors are, while V enum has more elements, display the next element plus space. Okay, initial capacity is 3. Capacity after 4 additions 5. Current capacity 5, 7, 9. 2 elements are added. First element is 1. Last element is 12. Okay, vector contains 3 as an element. And elements in the vector using enumeration interface are displayed from 1 to 12. Instead of relying on an enumeration to cycle through the objects as the preceding program, you can use the iterator. Okay, so enumeration is obsolete. It is not compulsory. Still you can use it, or you can also use the iterator interface. For example, we will see now iterator based code. Iterator integer, V iterator, V dot iterator, elements in the vector, while V iterator has next, display next element plus space. You can also use a for each style for loop to cycle through a vector as the following version. So now for integer I colon V, display I. As simple as that. Because the enumeration interface is not recommended for new code, you will usually use an iterator or for each style for loop to enumerate the contents of the vector or looping. Of course, much legacy code exists that employs enumerations till date. Fortunately, enumerations and iteration work the same way, so you don't need to learn new things. Stack. Stack is a subclass of vector that implements standard last in first out stack. Stack only defines the default constructor which creates an empty stack. With the release of JDK 5, stack was retrofitted for generics and declaration is class stack E, where E specifies the type of element stored in the stack. Okay. Stack includes all the methods defined by vector and adds several other methods. We will see them in the table. To put an object on top, you will use push method. To remove and return the top, call pop method. Okay, so more important thing to remember is remove and return. When you use pop, it not only displays, it also deletes the element from the stack. An empty stack exception is thrown if you call pop when the stack is empty. You can use peek to return but not remove the top object. Peek will only give you, return you, but not remove the top object. Okay. So methods defined by stack, we will see them one by one. Boolean empty returns true if the stack is empty and returns false if the stack contains elements. ePick returns the element but not remove. ePop returns the element plus remove it. ePush pushes element onto the stack. Element is also returned. Okay, which element you are pushing onto the stack, same element is returned over here using this E. Integer search object element searches for the element in the stack. If found, its offset from the top of the stack is written, otherwise -1 is written. Important thing to notice is its offset from the top of the stack is written as the primitive type int. Okay, so you have to remember this. The empty method returns true if nothing is on the stack. Okay, what is the meaning of this offset? If the top of stack, suppose we consider it as the index 0. Okay, and the element you are searching for, it stored at the index 2. So it will return you offset that is 2. Okay, from 0 to 2, how many elements are present there? 2. So it will return you true. 2. Okay. The search empty method returns true if stack is empty. The search method determines whether an object exists on the stack and returns the number of pops that are required to bring it to the top of the stack. Okay. So what is the task of the search method? it tells you whether an object exists first of all, and second, how many pops are there required so that your element will be on the top of the stack. Okay, here is an example that creates push and pop element. Important thing, java.util, you have to import, then pushing a element, stack integer st, show push method. The stack is over here and element is a. Push a, after it is pushing, it is displaying and also displaying stack. Okay, then pop. Pop will return you show pop stack into the st. So it will pop st.pop, it will remove, get it into a, and then it will display a and also display the stack. So first of all, we will create a stack from the stack class. Stack integer st is equal to new stack of type integer. Okay, so show push stack 42, 66, 99. Okay, show pop st, 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 and to not throw or handle the stack empty exception. It is handling or catching the empty stack exception over here. The following is the output. Stack is empty at first. After push 42, stack is 42 to 66. Stack is having 42 to 66. First in, last out. Okay. Push 99, 42, 66, 99. So first in 42, it will be out last. While popping 99 will be come out first. Then our stack will be 42, 66. Why? Because pop also deletes the element. Pop 66, stack is 42, pop 42, stack is empty, and pop is empty stack. Like empty stack exception, it is printing empty stack. Okay? Although stack is not deprecated with the release of Java 6, array dequeue is a better choice. Okay? So what is the replacement after Java 6? Array dequeue. Dictionary. Dictionary is an abstract class that represents key value store, depository, and operates much like a map. Okay. Dictionary is abstract class, first of all, that we have seen in the table, that represents key value store and operates much like a map. Okay. Like in map, we have key value pair. Given the key and value, you can store the value in the dictionary. Once the value is stored, you can retrieve by using its key. Just like a map, dictionary can be thought of as a list of key value pairs. Although not currently deprecated, dictionary is classified as obsolete because it's fully superseded by map. Nowadays, nobody uses the dictionary class. Everybody uses the map. Okay. However, dictionary still is used, not deprecated. We will see in detail with the advent of JDK 5. Dictionary was made generally. Its declaration is class dictionary key value pair, where key specifies type of key and K specifies type of key, V specifies type of value. The abstract methods are, now we will see, enumeration, elements, returns an enumeration of the values contained in the dictionary. We get object key, returns the object that contains the value associated with the key. If key is not in the dictionary, a null object is returned. Okay, so get will get the key from the dictionary. Boolean is empty, returns true if the dictionary is empty, and returns false if it contains at least one key. Enumeration K keys returns an enumeration of the keys contained in the dictionary. We put key value, insert a key and its value into the dictionary. Returns null if key is not already in the dictionary. Returns the previous value associated with the key if key is already in the dictionary. We remove object key, remove the key and its value, returns the value associated with the key. If key is not there, null is returned. Okay. We remove, it will remove the key and its value. Integer size, returns the number of entries in the dictionary. To add key and value, use the put method. Use get to retrieve the value of key. Key and value can each be written as enumeration by the key and elements methods respectively. The size method returns the number of key value pairs stored in a dictionary and is empty returns true when dictionary is empty. Okay. You can use the remove method to delete key value pair. Dictionary class is obsolete. You have to remember this. You should implement a map interface to obtain key value storage functionality for the nowadays program. Okay. Now we will see the hash table, fourth class. Okay. Hash table was part of the original Java util and is a concrete implementation of a dictionary. Okay. Dictionary is abstract. Dictionary was there and Java hash table was a part of that Java util package and it is the concrete implementation of dictionary. Okay. So with the advent of collection, hash table was re-engineered and also implement the map interface. Thus, hash table is now integrated into the collection framework. And it is similar to hash map, but it is synchronized. Hash table is similar to hash map class. Like hash table stores key value pairs. Neither keys or nor values can be null. And also one more thing to remember it is synchronized. When using hash table, you specify an object that is used as a key and the value that you want linked to that key. The key is then hashed and the resulting hash code is used as the index at which the value is stored within the table. Okay. Hash table was made generic by Java 5. It is declared like this class hash table key value. Okay, where key specifies the type of key and we specify the type of value. The hash table can only store objects that override the hash code and equals methods that are defined by object. Okay. So what is that? It can only store objects that override the hash code and equals method that are defined by class object. Must compute and returns the hash code for the object every time. Equals compares to object. Fortunately, many of the Java's built-in classes already implement the hash code method. So no need to worry about it. The most common type of hash table uses a string object as a key. String implements both hash code and equals. Okay. So what is the criteria? Must compute and return the hash code. And fortunately, many of the Java's already inbuilt classes already have implemented the hash code method. Okay. String implements both hash code and equals. What is the example? Most common type of hash table uses a string object as the key and it is already implementing hash code and equals method. So now we will see hash table constructors. Hash table default constructor. Second one is integer size. Creates a hash table that has initial size specified by size. Default is 11. Hash table integer size float to field ratio. This type of constructor we have already seen. Creates a hash table that has initial size specified by size and field ratio specified by field ratio. This ratio must be between 0.0 and 1.0 and it determines how full the hash table can be before it is resized upward. Okay. Specifically, when the number of elements is greater than the capacity of the hash table multiplied by its field ratio, the hash table is expanded. Okay, this type of constructor we have already explained. The same way it is over here and the default field ratio is 0.75. Hash table map extends K extends V M creates a hash table that is initialized with the elements in the map object. Capacity of the hash table is set to twice, that is double the number of elements in map. The default load factor is 0.75. In addition to the methods defined by map interface, which hash table now implements, hash table defines the legacy methods. Okay. Several methods throw null pointer exception if an attempt is made to use null key or value. The legacy methods by hash table, void clear resets and empties the hash table. Object clone returns a duplicate of the invoking object. Boolean contains object value, returns true if some value return equal to value exists within the hash table. Returns false if the value is not found. Boolean contains key, object key returns true if some key equal to key exists within the hash table. Returns false if the key isn't found. Then Boolean contains value, object value returns true if some value equal to value exists within the hash table. Returns false if the value is not found. Enumeration elements returns an enumeration of the values contained in the hash table. We get object key returns the object that contains the value associated with key. If the key is not found in a hash table, null object is returned. Boolean is empty returns true if hash table is empty. Returns false if it contains at least one key. Okay, so at least one key is there, it will return false. Enumeration keys returns an enumeration of the keys contained in the hash table. We put k key, we insert a key and value into the hash table. Returns null if key is not already in the hash table. Returns the previous value associated with the key if key is already present. Okay. Void rehash increases the size of the hash table and rehashes all of the key. Okay. We remove object key, remove the key and its value, returns the value associated with that key. If key is not in the hash table, a null object is returned. Integer size returns the number of entries in hash table. String to string returns the string equivalent of the hash table. The following example reverse the bank account we have already seen. It uses hash table to store name of a bank and its their current balances. Okay. In account, hash table string double balance, new hash table string double. Enumeration to iterate, string double balance, John Doe, Tom Smith, Jane Baker, Toad Hall, Ralph Smith. Okay, so all balances, balance dot key. Okay, show all balances in hash table. It will get balance. This is the balance hash table name dot keys. All keys are taken into name. While names has more elements, names dot next element it's taken and it is balance dot get key. It will give the value of the particular name. If I pass the John Doe, it will return the balance of the particular John Doe element. That is balance, account balance. Then deposit balance dot get John Doe, balance dot put John Doe plus 1000 currency and new balance is displayed. Toad Hall, Ralph Smith, John Doe, Jane Baker, Tom Smith. So it is a re-engineered program that is we have already seen previously. Only the different is we implemented it using hash table. One important point like the map classes, hash table does not directly support iterator. Okay. The preceding program uses an enumeration to display the contents of the balance. Okay. So what you have to remember, hash table does not directly support iterator interface. So to iterate or to look what you have to do, you have to use an enumeration. However, you can obtain set view of a hash table which permits the use of iterator. So what you will do for this type of entries, you have to find out the set view of the particular collection and particular group of object and then use the iterator interface. You simply use one of the collection view methods defined by map such as entry set or key set. So it will give you the set view and to iterate through it, you will use the iterator interface. For example, you can obtain a set view of key and cycle through them using iterator or an enhanced for loop. So now we will again rework version of this program. Hash table balance, new hash table string double. Okay, John Doe, Tom Smith, Jane Baker, Toad Hall, Ralph Smith. Balance dot key set. So it will give you the set view. This set view is stored into set string, set of type string, and get an iterator. Set dot iterator. Okay, so this iterator will look into the hash table. While iterator has next, iterator not next, and what it will do, it will get the element as a key and balance dot get key. It will return its value. So key is here and value is here. Okay. Then again deposit 1000 currency into John Doe's account. Balance is equal to balance dot get John Doe. Then put 1000 currency into that and new balance is also displayed. Okay. Next is properties. Properties is a subclass of hash table. It is used to maintain list of values in which the key is string and the value is also string. Okay. So subclass of hash table is property. You have to remember the properties class is used by many other Java classes. It is the type of object written by system.getProperties when obtaining environmental variables or environmental values. So property is used by many other Java classes. Although the properties class it is not generic, several of its methods are. Okay. Properties is not generic, but its methods are generic. So what is the instance variable defined by properties? Properties default. The variable holds default property list associated with the property object. So two constructors are there. Properties creates a properties object that has no default values. Property default creates an object that uses property default for its default values. Both the both the cases property list is empty. Here is also it is empty. For default constructor creates a properties object that has no default values, and property default create an object that uses property default for its default value. In both the cases property list is empty. In addition to the methods from hash table class, its own methods we will see in the table. Properties also contains one deprecated method save. This was replaced by store because save did not handle errors correctly. Okay. Did not handle errors is the main thing, and correctly is very important thing because it was handling errors but not correctly. So it was replaced by store, and so this save method is deprecated. One useful capability of the properties is that you can specify a default property that will be returned if no value is associated with a certain key. Okay, so key value in the key value pair, if there is no value associated with that key, it will give the default value or default property. The default value can be specified along with the key in that getProperty method, such as getProperty name default value. If the name is not found, it will return the default value. When you construct a properties object, you can pass another instance of properties to be used as the default properties for the new instance. Okay. That means when you are creating the property object, you can pass another object of property to be used as the default property for the new instance. You call getProperty foo and a given property object, and foo does not exist. Java looks for foo in the default properties object. And this allows for arbitrary nesting of labels of default properties. Okay. The methods defined by properties, we will see them one by one. String getProperty, string key returns the value associated with the key. A null object is returned if key is neither in the list nor in the default property list. String getProperty, string key, string default property return the value associated with the key. Default property is returned if key is neither in the list nor in the default property list. Void list prints string out, sends the property list to the output stream linked to stream out. Void list print writer stream out sends the property list to the output stream linked to stream out. Then void load input stream input throws IO exception. Inputs a property list from the input stream linked to stream input. Void load reader stream input throws IO exception. Inputs a property list from the input stream linked to stream input added by Java 6. Void load from XML input stream input throws IO exception. Invalid properties format exception. Inputs a property list from an XML document linked to stream input. Enumeration property name returns an enumeration of the keys. This includes those keys found in the default property list too. Object set property, string key, string value associated value with the key, returns the various value associated with the key, or returns null if no such association exists. Void store output stream out string description. After writing the string specified by description, the property list is returned to the output string linked to stream output. Void stores writer stream out write string description throws IO exception. After writing the string specified by description, the property list is returned to the output string linked to stream out added by Java 6. Void store to XML output stream out string description throws IO exception. After writing the string specified by description, the property list is returned to the XML document linked to stream out void store to XML output string, string out, string description, string inclusive, string encoding. Sorry. The property list and the string specified by description is written to the XML document linked to stream out using the specified character encoding. Set string get property string property name returns to set of keys added by Java 6. Okay. So now the following example we will see for properties. It creates a property list in which keys are the names of states and the values are name of their capitals. Notice the attempt to find capital for Florida includes the default values. Okay, if no value is there, it will give the default property, and this is the advantage of properties class. So now properties capitals, new properties are created. For capital is a property object name. Capital dot put here Springfield, Jefferson City, Washington, Olympia, California, Sacramento, Indiana, Indianapolis. Set states capitals dot keyset get the set view. Show all of the states and capitals for each style for loop object name state. The capital of name is capitals dot get property casted to string because we are getting the object, not string. So we are particularly casting to string and displaying the name. Okay. Look for state not in the list specified default. Capitals dot get property Florida not found. Okay. Here Florida is not present. So what it will do? Capitals dot get property Florida not found. If it is not found, it will display not found. Capital of Missouri Jefferson. Capital of Illinois is Springfield. Capital of Indiana is Indianapolis. Capital of California is Sacramento. Capital of Washington is Olympia. The capital of Florida is not found, which is the default property. Since Florida is not there, default value is used. Although it is perfectly valid to use default value when you call get property. As the preceding example, there is a better way of handling default value for most applications of property list. Okay, so better way is always present there. For greater flexibility, specify greater default property list when constructing the property object. Okay, so this is the one way for assigning the default value. There is better way available. Default list will be searched if the desired key is not found in the main list. Okay, it is like when you are using the switch case. Okay, we have seen the switch case. In the switch case, default is present. If no value is present in switch, the default one is used. The following is slightly reworked version of the preceding program. If Florida is sought, it will be found in the default list. Properties default list, new properties Florida, Tallahassee, Wisconsin, Madison. Properties capitals, new properties, default list. Okay. In the default list, we have put key with a value. And then get a set view of the keys, capitals dot key set. Then for each style for loop for object name in the particular state. State is the name of property. State is the property name of the set view. So we are iterating into the set view and returning Florida will not now be found in the default list. Capitals dot get property Florida. So in the default list we have created default list we put here, so we can add as many elements over here, and in the bracket of main properties we will add the default list. If any value is not found in this property in this list, it will be found in this second default list. Okay, so capitals dot get property Florida. The capital of Florida is string presented. Okay, so now next is using store and load. One of the most useful aspects of properties, information content in the property object can be easily stored or loaded from disk with the store and load method. So very important topics we are going to see with the properties. Okay, so whatever you want to store, you can store it using the store, and whatever you have to fetch, you can fetch it using the load method. You can write properties object to a stream or read it back. This makes property list especially convenient for implementing simple database. The following program uses the property list to create a simple computerized telephone book that stores name and phone number. So you have to enter your name so that using that name, you can find out its mobile number or phone number. And for that, it uses the store and load methods. It first tries to load the list from a file called phonebook.dat. Okay. If the file exists, list is loaded. You can then add to the list. If you do, the new list is saved when you terminate the program in the file called phonebook.dat. Notice how little code is required to implement a small but functional computerized phone book. Okay. So properties object is created. Buffer reader is equal to new input stream reader system.in. Name and number is there. Then if input stream object is null, boolean change is equal to false. Phonebook.dat is a file that have the key and value pair, name of the person and phone number of the person, and that object is open as file input string. So this file will be read. We have already seen the file handling. If file is exists, it will load the existing telephone numbers. If not null, ht.load ft. Okay, and after that it will close. Error reading file is not present. Now you let the user enter new names and numbers. New name will be read line. Name equals quit. Continue. Okay. Enter number. Number is also read line from a console. Then put name and number into the file. Change is equal to 2 while not name equals to quit. What it will do? It will read the file. It will read the contents, phone number and name from the user, and it will put into HT. What is HT over here? Is the property object. Okay. If change is equal to true, for output stream, phonebook.dat file is open for writing, and it will write the data ht.store telephone book, and it will close. Okay. This is the load method to read from file, and this is the store method to write to a file. Okay. Now enter name to find. So name will be entered by user. Name equals quit. Continue. Then number is equal to, if name is not equal to quit, it will get a name from your HT properties object. That is property this dat file. What is the name of dat file? Phonebook.dat file. And then it will print the number of that particular person. It will run unless and until name is not equal to quit. Okay. So parting thoughts on collection. We will summarize now. The collection framework gives you the programmer a powerful set of well-engineered solutions to some of programming most common tasks. Okay. So well-engineered solutions are there for building collection. The Java inventor have done so much work for that, and they have engineered so many solutions, a powerful set of the solutions, so that very common tasks can be done very much easily. Okay. The collection framework is generic. It can be used with complete type safety. So you can store more elements with the type safety as well, which further contributes to this value. Consider using a collection next time that you need to store and retrieve information. Okay. So collection is very easy to use, easy to understand and remember. Collections need not be reversed for only the large jobs such as corporate databases, mailing list, or inventory system. Okay. So for small tasks also you can use the collection. They are also effective when applied to smaller jobs. For example, tree map would make an excellent collection to hold the dictionary structure of sets of files. Tree set would be quite useful for storing project management information. Okay. For smaller programs or projects, you can also use the collection framework. Frankly, the types of problems that will benefit from a collection-based solution are limited only by your imagination. Okay. So you may think of that collection is a very vast thing. There are so many interfaces to remember. There are so many methods in that interfaces. So many classes that those implement that interfaces. And there is such a vast thing. So whenever we will build a very large Java applications, we will use them. It is not like that. It is not limited. It is only limited by your imagination. For simple task also you can practice collection. You can use collection so that whenever you will go for the next step, that is a very large step for building a very large Java applications at your job profile or at your in your business side or your own Java application. You can use collection very well easily. Okay. So this way we have completely done with the collection framework theory part. In the next session, we will move for the practical part and then the collection framework is now ended and new topic will be started. Okay. So enjoy collection framework, practice them, learn the new things, remember them. Okay. Use as many functions, as many methods in your Java applications as you can, so that when you will go for actually working with a real life, real world application, you will find out it easy. Okay, it is not a hard thing, it is vast. I agree, collection is a vast thing to remember. Okay, so there are so many things to remember, so many things to learn, but nothing is more dangerous. When you are practicing everything, everything is easier. Okay, so practice it, enjoy Java programming. Meet you in the next session. Thank you so much.